We're continuing on with quadratics, and we're starting with some applications. Now, the ones I'm going to show you here are not universal. There's many types, and these are not the ideal ones. We'll later see some more that I like. But the function of it is that we're going to know a lot about a quadratic because if it is upside down, so if that a is a negative, then the vertex here is going to be the peak. It's going to be the top of the hill. And so this is used in physics and stuff all the time to say this is the projectile problem. Where is it at its highest point? We can also find where it hits the ground. There's lots of uses of this here. Now the first one here, we're going to talk about a garden, and we're thinking, well, how could we turn this into finding the maximum value for the maximum area? Well, we can actually do it. So they've told us here that we are going to let's get to our picture here. So here's what we've got. We've got a length and a width, and they're telling us that we have 80 feet of fencing that we've bought. So it's, I guess, a house, or something like this. So we had a length and a width and a length. We didn't have a second width because it was against the house. And we can create this formula here because I had 80 feet of fencing. So we're just using the perimeter, okay? All right, now we're going to solve that for W, and I have this. Now they're also telling us that we have the area, which is obviously the length times the width gets us the area of a rectangle. Well, if I drop this in for W, I've only got one I don't know now. And we multiply that out and we come this formula. So we took the perimeter. Now there weren't two widths, there was only one. We solved it for W. Now we put that into the area formula, length times width. And now here's what we've got. We have a function here for the area of this backyard, this fencing, and it's based on the length. Now, how could we find the maximum value for this area? Well, this, because it's -2, I don't know if they changed this, this is a quadratic equation. And it's a negative, which means it's upside down. So if we can find the value of that vertex, we will have the h would be the length, the maximum length, and the a, so remember the vertex is hk. If I find h, then I have the length that maximizes it. If I have k, I would have the height, or the area that maxes. So this would be the area, and this would be the length. So h would turn out to be the length that gets us to the peak, the maximum, and k would turn out to be the y value, which is the area that would tell us the maximum area. Okay, so we're just doing the same thing we did in the last video, -b/2a. We crunch that, and we get an h of 20. So that's a length. That is the maximum length. And if you put it into the equation, we would get the maximum area, which would be 800. So they've got it diagrammed for us. That's the vertex. Well, that's the max length. That's the max area. Okay, what are they doing here? Oh yeah, this one is really convoluted. There's so many better ones than this. I don't like this. But what they're saying is that it's clever, but this is not what I would normally want to give you. They're telling that we have a point here. So when they charge $30, this is how many subscribers they get. When they charge $32, we now have 5,000 less subscribers. But here's what that's saying. We actually have 2 points there. At $32, we have 79,000 subscribers. At $30, we have 84,000. Well, let's find the slope between these two points. And when we do, we've got -2,500. I'm just finding that slope. Okay, so I have the slope, but I don't have the y-intercept. Well, let's find it. We know a point that's on it is that $30 gets me this many subscribers. We can find b. Well, we get b is then 159,000 is our y-intercept. So here's what we've got. We've got an equation that tells us about how many subscribers we have based on how much they're charging. I don't know why they chose these initials that they did for the variables. Now, revenue, again, this is a really difficult one. I think there's many that are much better than this, but revenue is the price times the number of subscribers. Okay, well, we have subscribers. It's this formula. So I'm going to take the price and multiply it by how many people we have, how many subscribers. That's how much money we're making, how much it costs us, or how much we're selling it for, and how many subscribers. Okay, well, we crunch that out. Look what we've got again. We have a quadratic equation. So if we want to maximize our revenue, and look here, the A term is negative, so it is upside down. And if we can then find the vertex, I don't know what even remember what we were asking, but we can find, yeah, so we're going to find the max revenue if we find K. So if we find H, that is the cost. If we charge $31.80, plug that back into the equation, our maximum revenue is $252. This is just the K. It's just because that shape is upside down. The vertex gives us really important information about the maximization. Okay, I don't know what all else is in here. I know we're going to talk here about x and y intercepts. Of course, you could have a parabola that doesn't ever hit the x-intercept. Maybe you just barely touch it, or maybe you cross twice. So finding this is no different than it always would be. If I want to find an x-intercept, it's when y is 0. So I'm putting 0 in for y. So we're going to factor this and solve. Though they went the other way around. Let me finish it then. Okay, now you could use the AC method, whatever you needed to do here. I'm not going to talk you through the factoring, but I factored this. So I get x is 1/3 or x is -2. So these are the places, these are my x-intercepts. They occur when y is 0. Now, how about the y-intercepts? The y-intercepts occur when x is 0. So that's what they were doing on the slide I showed just briefly. If you put 0 in for x, what do you get for y? Well, that's all 0. You would get a y-intercept. If you put in x is 0, you get out -2. Do you see just from that guy? Everything else fell out. Wow, that was it. Okay, I wish I'd had more examples there. Sometimes this book is a little bit sparse. Some of their books are really thorough, and this one's a little thin here. But I think it's all should be pretty intuitive, and that should get you going. So that is going to just do some basic applications, but the key is always the vertex. If it's upside down, then that vertex is then the maximum point, and it can have lots of applications. And then it's pretty easy to find the x and y intercepts. X-intercepts when y is 0, y-intercepts when x is 0.